What's going on, everybody? Welcome back to my YouTube channel. Now we have this question on the board which says find all number triples x, y, and z such that x plus yz is equal to 2, y plus xz is equal to 2, and z plus xy is equal to 2. Well, I'm going to be calling this first equation, equation 1. I'll call this equation 2, and I'll call this equation 3. So our first step will be to subtract equation 2 from 1. So let's go ahead and subtract equation 2 from equation 1. We're going to be having x minus y plus yz minus xz equal to 0. Now our next step will be to rearrange this equation. Why? Because if you notice, you see that x here comes before y. So we're going to be arranging these two such that x comes before y. So we have x minus y minus xz, so minus xz, then before plus yz. That's it, equal to 0. So you notice that z is common here, so we're going to be factorizing out z. So we have x minus y minus, now bringing out z, we have x minus y remaining equal to 0. Cool. So notice that x minus y is common. So which means we can also factorize x minus y out. So let's bring it out. X minus y. Now what is going to be remaining here? 1 minus z. So that's it. Equal to 0. Now you see that we have two cases. We have x minus y to be equal to 0, or we also have 1 minus z to be equal to 0. So for the first case, we see that x is equal to y by moving negative y to the right hand side. For the second case, we see that z is equal to 1. So we're going to be solving these cases one after the other. So let's start with the first case. So we'll call this case 1. So for case 1, this is when x is equal to y. So that means x and y are equal. Wherever I see y, I'm going to be substituting x. So let's substitute this into these three equations. So starting with the first equation, wherever I see y, I'll be putting x there. So let's go. So we have x plus xz equal to 2. So since I have equation 1, 2, and 3, I can go ahead and call this one equation 4. Now, substitute this into equation 2. When we do that, you notice that we have the same expression as this. So no need. Now, let us put this into equation 3. We're going to be having z plus x squared to be equal to 2. So let's go ahead and call this one equation 5. So from equation 5, I can go ahead and make z the subject so that we can substitute it into equation 4. So let's do that. So making z subject, I'll have z to be equal to 2 minus x squared. So we're going to be moving this, which is, let's call it equation 6, and put it into this equation, which is equation 4. So let's do that real quick. So substituting z equal to 2 minus x squared in equation 4, we're going to be getting x plus x. Now look at z. I'm going to be putting 2 minus x squared. That's it. Equal to 2. So let's go ahead and expand this. So we have x plus 2x minus x cubed to be equal to 2. So this can be added together. So x plus 2x is 3x minus x cubed to be equal to 2. Now notice that we have a cubic equation. So let's go ahead and move negative x cubed to the right hand side. So we have x cubed. We also move 3x to the right hand side. So we have negative 3x. We've already got 2 here. So write plus 2 equal to 0. So I'll be making use of the factor theorem to factorize this cubic equation. So one of the factors of x cubed minus 3x plus 2 is x minus 1. And dividing x cubed minus 3x plus 2 by x minus 1, I'll be having x squared plus x minus 2 equal to 0. And this can further be factorized as x minus 1. And since I have a quadratic equation here, this quadratic equation is factorized into x minus 1 times x plus 2 equal to 0. So you notice that I have the same expression here. So x minus 1 times x minus 1 is x minus 1 squared. Good. So x plus 2 equal to 0. So we have two cases where we have x minus 1 equal to 0, or we have x plus 2 to be equal to 0. So from this first case, x is equal to 1, and from this second case, x is equal to negative 2. So working with x equal to 1, remember that we are dealing with the first case, which says x is equal to y. That means as x is equal to 1, the value of y is also 1. So let's substitute this into the original equation. We can put it into any of the original equation. So let's put it in the first, which is x plus yz equal to 2. So from the original equation, this is our equation 1. So let's put it here. So x is 1 plus y is 1 times z. So that is 1 times z is z. That's it, equal to 2. So this shows that z is equal to 2 minus 1, which is equal to 1. So the value of x, y, and z from this case is equal to 1, 1, 1. That's it. So now we're going to be trying for when x is equal to negative 2. And also remember that when x is equal to negative 2, y is also equal to negative 2. So let's substitute this into the same equation 1. So x is negative 2. So let's put negative 2 there. Plus y. Y is also negative 2 times z equal to 2. So this expression results to negative 2z to be equal to 2. So when I move negative 2z to the other side, I get 2z equal to, this becomes negative 2, which results into negative 4. So the value for z, y dividing both sides by 2, is equal to negative 2. So other value pairs for x, y, and z is x is negative 2, y is negative 2, and z is also negative 2. So this is for our first case. So now let's solve for our second case. So our second case, we have z equal to 1. This is very easy because looking at equation 1, 2, and 3, you notice that the equations are symmetrical, which means that even when I interchange the position of x, y, and z, I'm still going to be getting the same result. So if z is equal to 1, it goes to say that y should also be 1 and x is equal to 1, which means we also have the triple x, y, and z to be equal to x1, y1, and z1. So we have this value already, and the other value we got is negative 2, negative 2, negative 2. So these are the triples x, y, and z. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.